Happy snowy Thursday, everybody. We are in chapter 4, section 1, lesson number 2, talking about needing one equation or two. So before we get to that, a couple announcements for all of us. Homework collection number 3 is going to be posted this week, later today probably, and make sure you get that filled out. It's on lessons 411A and 411B from Monday and Tuesday. Again, make sure you show your work when you submit your pictures. Make sure you are consistently doing your homework, because again, homework is 15% of our semester grade this time around, and if we don't do it, that's a really big chunk missing, and we're only hurting ourselves by not doing any homework. So another announcement is you should have taken that Chapter 3B test by now. If you have not done so, please do so as soon as possible. They will be in the gradebook probably by the end of the day today. If you have not taken it, it's probably is missing, and it probably means you got an F right now. So not good stuff if you don't have that done. Please get that done as soon as possible if you have not yet. Next thing, if you are able, or if you do not have the Chapter 4 stuff yet and you're able to come into school, especially if you're an all virtual person, please come into school and pick up the Chapter 4 stuff for Algebra 1. The material pickup is today after school and also tomorrow, Friday, February 4th, all day long. Stop in anytime on Friday as well. And the big one here before we jump in is Monday's video. Monday's video is super important that you watch that for section 4.2.1. That is absolutely not optional. If you do not do that lesson, you will be in a very bad spot going forward in Algebra 1. So please make sure that we are diligent, responsible, and taking care of what we need to take care of for this class, because this lesson, 4.2.1, is super important. So that being said, enough announcements, enough of homework and upcoming things. Let's talk about some Chapter 4 stuff. I'm going to flash the homework up really quick, so if you want to check this out, pause the video right here. Otherwise, moving on. So 4.1.2, one equation or two. So in the last lesson, we created mathematical sentences that represented word problems, and today we're going to do the same thing, but with two equations. So we're going to explore how to use the equal values method to solve a system of equations, and we're going to talk about that in just a second here. So we're going to work up to that through our problems today. So we're going to jump in with 420. So Elsie took all her cans and bottles from home to the recycling plant. The number of cans was more than 4 times the number of bottles, the number of cans was 1 more than 4 times the number of bottles. She earned 12 cents for each bottle, 10 cents for each can, and ended up earning $2.18 in all. So we want to know a couple things here. First thing we want to know is how many cans did she have? And the second thing is how many bottles did she recycle? So how many cans and how many bottles are we recycling? Solomon decided to solve that problem by writing an equation. He said, I let B be the number of bottles. Let B be the number of bottles, and then let 4B plus 1 be the number of cans. So his overall equation is right here. We've got 12B plus 10 times 4B plus 1 is equal to 218. So how are we getting 218? How are we getting 218? Where's that 12 coming from? Where's that B coming, or that 10 coming from? So I think the 4B plus 1 again is the number of cans, right? Because we have 1 more than 4 times the number of bottles. So this is our number of cans. We know that we get 10 cents for each can. We get 12 cents for each bottle. So that makes sense that we put that 12 in front of our variable for B, because B is standing for the number of bottles. 4B plus 1 is our number of cans. We get 10 cents per can. So we get 10 times 4B plus 1. And then if we convert $2.18 into cents, we know that every dollar that we have 100 cents. So we have 218 cents overall. So I like that equation. I think that one makes sense. So Marcus agreed with Solomon's answer, but he said it's easier to solve this problem with 2 equations. So here's what Marcus said. I let B represent the number of bottles and C represent the number of cans. So basically he's doing Solomon's thing in 2 different steps here. Let me get my lights back on quick. Come on, there we go. So Marcus's two equations are, I'm going to change my highlighter here. He's got C is equal to 4B plus 1, and then second of all, he's got 12B plus 12 or 10C is equal to 218. All right. So let's take a look at Solomon's equation yet again. We've got three terms, 12B, 10 times 4B plus 1, and 218. What do these terms represent in the problem? We kind of talked about this a little bit already. Again, 12B, that's telling us that we have 12 cents per bottle. The 12 is 12 cents per bottle. Per bottle. And that B is the number of bottles. So again, we also talked about this next term. Again, that 10 is telling us that we get 10 cents per bottle, or it's not per bottle, but this time it's per can. Per can. And then that 4B plus 1, because we know that the number of cans is 4 times more than the number of bottles, and then adding 1 is, that quantity is our number of cans. And then lastly, we already talked about that 218 is the total amount of cents. Total amount of cents, where we know again that $2.18 is exactly the same thing as what we have in our equation, which is 218 cents. Just like that. Those two things mean the same thing. So that's what our three terms mean in that equation. Let's go on to part C at the very bottom part of the page. Sorry, part B. So if we look at the different parts of Marcus's equation, again, Marcus's two equations were C is equal to 4B plus 1, and then we also had 12B plus 10C is equal to 218. So I think all of these things are representing exactly the same thing. The only difference is we've got this second equation that is talking about the number of cans in just a little bit different way with our variable of C. So I think the parts mean exactly the same thing. That 12 in front of our B is saying we got 12 cents per bottle. B is the number of bottles. 10 is saying 10 cents per can. C is the number of cans, where C is equal to 4B plus 1. And then our overall total for cents is 218. So they do represent exactly the same problem. This have the same exact value for each of their variables. Again, it's just represented just a little bit differently, and that's what part C is asking for us. Yes, they are representing exactly the same problem, just a slightly different way. So let's take a look at the next page. Let's go to 420 part D. We're going to solve this equation. We do not need Marcus's equation. We're going to solve Solomon's equation. So we've got 12B plus 10 times 4B plus 1 is equal to 218. So the first thing we're going to do is solve for B. And again, our overall goal with this problem is to find the number of bottles and cans that our friend Elsie is recycling here. So that's what we're trying to find the number of bottles and cans overall. So if we solve for B, that's going to give us one of those variables. So perfect. Let's solve this equation. So our first instinct, hopefully, is whenever we see something multiplied into a set of parentheses that we need to distribute what is ever on the outside of those parentheses. So I think hopefully, again, our instinct is to take this 10 and distribute it to both terms inside of our parentheses here. Again, we leave alone that first term, 12b, because we only multiply the thing that is touching the parentheses. So our equation, once we distribute, would look like this. 12 times b, that stays the same, plus 40B, because we multiply those numbers together. And then we're adding 10. And that is equal to 218. So now before we can solve for b, let's combine our like terms on the left-hand side over here. So 12b plus 40b is equal to 52b. Not the b-52s, but 52b plus 10 is equal to 218. Now we can simplify across the equal sign, so let's get rid of that 10. Moving that from left to right, so we're subtracting 10 from both sides. Our 10s are going to cancel on the left, and we are left with 52 multiplied by b is equal to 208. 208. So if we divide both sides now by 52, because we have to undo the multiplication of 52 times b, we get our number of bottles, which would be 208 divided by 52. So our number of bottles is 4. So we get 4 bottles for this equation. Perfect. Now how do we find the number of cans? Number of cans. Again, if we think back to the very beginning of this problem, the number of cans was represented by this chunk right here, 4b plus 1. So if we plug 4 in for b, let's solve for the number of cans. 4b is minus 1. It equals the number of cans. So let's plug 4 in. So 4 times 4 plus 1, not minus 1, plus 1 is equal to the cans. So 4 times 4 is 16. We add 1 to 16, we get 17 cans. So in total for this problem, we're recycling 4 bottles and 17 cans. There we go. So let's see if there might be a more efficient way to solve that problem. Let's maybe take a look at 21 and keep rolling here. So Renard, I think that's Renard, thought that writing 2 equations for problem 420 was easy, but he's not sure if he knows how to solve that systems of equations. So he wants to use 2 equations with 2 variables to solve the following problem. So Ariel bought several bags of caramel candy and taffy. The number of bags of taffy was 5 more than the number of bags of caramel. So let's start with that piece of information. Let's highlight that. That seems pretty important. The number of bags of taffy was 5 more than the number of bags of caramel. Taffy bags weigh 8 ounces each, and the caramel bags weigh 16 ounces each. The total weight of all the bags of candy was 400 ounces. So I think that piece of information is going to be separate from the one that I just highlighted in yellow, because the first thing we're just talking about number of bags. The second thing we're talking about weight. So we have weight for each bag of taffy, weight for each bag of caramel, and the overall total weight. So I think we need to write an equation for the stuff in yellow and also for the stuff that I am highlighting currently in green. So I think we need 2 equations, one for yellow, one for green. So let's get to it. Let's start with yellow. So our yellow equation, we have the number of bags of taffy was 5 more than the bag of caramels. We're going to say first that T is equal to the number of bags of taffy, and then we're also going to let C equal the number of bags of caramel. So if we know the number of bags of taffy is 5 more than the number of bags of caramel, we could say for our first equation that T, the number of bags of taffy, is equal to the number of bags of caramel plus 5. Right, because we know from our yellow directions, number of bags of taffy, 5 more than the number of bags of caramel. So there's our first equation. Our second equation, let's write one that represents that green sentence in our paragraph here. Taffy bags weigh 8 ounces each, and the caramel bags weigh 16 ounces apiece. The total weight of all the bags of candy is 400 ounces. So the 400 ounces is our total. So let's say 400 equals. And now let's go back and see if we can figure out the next 2 terms. Again, we're probably going to have 2 variables again. So we know taffy bags weigh 8 ounces each. We don't know how many bags of taffy we have, but we do know that we have 8 ounces per bag of taffy. And we're adding the bags of caramel, which are 16 ounces apiece. So we have 16 ounces per bag of caramel. So if we take 16 times C, I think that might be a good way to represent for that. So now let's go to part B. Renard is stuck. He says if both equations were in the form t equals something, I could set the two equations equal to each other to find what that solution is. So we already have our red equation over here is already set equal to, or set as t equals something. So let's rearrange this equation and solve for t. So we're going to solve for t for our second equation. We're going to solve for t in our second equation. We're basically just going to rearrange this one. So I'm going to write it as is. So 400 is equal to 8 times t plus 16c. So the first thing we got to do, if we're going to solve for t, we got to get this term by itself. So we need to get rid of our 16c from the right side. So let's subtract 16c from both sides. So if we do that, the 16c's cancel here. Our next line should read 400 minus 16c is equal to 8 times t. And now we got to do one more step to get t by itself. We got to divide everything by 8. So we got to divide everything by 8, everything by 8. Our 8's cancel over here. And when we divide on the left-hand side, we are left with, should be equal to 50 minus 2c is equal to t. So we just took this, moved it that way. So we got two equations now set equal to t. I'm going to rewrite both of those underneath. So our red equation from above is t is equal to c plus 5. Our green one that we just rearranged is t is equal to 50 minus 2c. So the beauty of equality is if we know that two quantities are equal to the same thing, they are equal to each other. So for what that means is if we have this c plus 5 is equal to t, 50 minus 2c is equal to t. So that means that these two things are equal to each other because they are both equal to t. So what that means is we can write an equation now with one variable. What that would look like is c plus 5 is equal to 50 minus 2c. And I think we should be pros at solving for one variable. So again, we can take, what we did was take those two things, set them equal to each other. And now we can solve for c, which is going to tell us the number of bags of caramel that we have. So let's solve for c. Let's consolidate our like terms on either side of that equal sign. I'm going to start by moving my 2c, sorry. So adding 2c's to both sides, because I like to have positive variables. So we're going to move that over. So we have 3c plus 5 is equal to 50. Now we can move our 5 right here from left to right. So we got to subtract 5. Subtract 5. Cancel, cancel. 3c now is going to be equal to 45. And then our last step, hopefully you're getting ahead of me. Divide by 3, divide by 3. Boom. And we should get our c, or number of bags of caramel, to be equal to 15. Perfect. So that's one part of our equation. Now, what we got to do is we got to figure out how many bags of taffy do we have. So now that we have this point, we know how many bags of caramel we have. What we can do is we can take this value and then plug it back into either one of our original two equations to find our value for t. So I'm going to plug it into the red one because that one's pretty straightforward. We're just adding two things together. So we know that the bags of taffy, t is going to be equal to our value for c, which is right there, is 15. We have to add 5 to it. So the number of bags of taffy is 20. And there we go. So we just solved the systems of equations. We had two equations with two variables. If we can solve for the same variable in both equations, we can set those two things equal to each other and then solve for the values where they are going to be the same. So what that looks like a little more algebraically is what we're going to talk about next in 22. 22, we are going to, we already did that part, so we're going to skip that. 22 is next. So we're going to take these two equations on the right. We've got x minus 2y is equal to 4, and then y equals minus 1/2 x plus 4. So first things first, what I want to do is, if we look at our top equation here, I'm going to highlight that one in green. Right now we have a line that's in standard form. We get a line that's in standard form. I want to rearrange it. Excuse me. I'm going to rearrange this now that it's in y-intercept form, or slope-intercept form, just like we have on the one underneath it. So let's rearrange this one. I'm going to rewrite it off to the side here. We've got x minus 2y equal to positive 4. We want to solve for y. So the first thing we got to do is move our x. Let's subtract x from both sides. Cancels here. Oops, cancels. Minus 2y is equal to minus x plus 4. And we want that looking like slope-intercept form. So now we got to get our y by itself. Let's divide by a -2. So we got to divide everything by -2. Divide by -2. Those -2's cancel. We're left with y is equal to, we have negative and a negative. Our signs always cancel when we have the same two things, whether it's multiplication or division. Excuse me. So this is going to be 1/2 x minus 2 once we divide by -2 over here. And this is our second equation now. So we got y equals 1/2 x minus 2. I'm going to take this equation and rewrite it here underneath. So we've got y equals 1/2 x minus 2. Y is equal to negative 1/2 x plus 4. Perfect. And now we have two things that are both equal to y, so they are equal to each other. So now let's set those things equal to each other. We're going to solve for y and see what we get. Or not solve for y, we're going to solve for x. So let's set these two things equal to each other and solve for x. Again, our red equation is 1/2 x minus 2. We are setting that equal to minus 1/2 x plus 4. And now we can solve for x because we're down to one variable. We can combine our like terms across our equal sign and we can solve for x. So let's, first things first, add 1/2 x to both sides. We're going to add 1/2 x. So these two terms cancel over here. We have a half plus a half. Hopefully we all know that that is equal to 1x. So x minus 2, oops, let's make that actually look like a 2. So x minus 2 is equal to a positive 4. We want to get our x by itself, so we got to add 2 to both sides. Perfect. So x is equal to 6. There we go. So that is the first step in solving this systems of equations. That's the first part of our solution. Again, if we have two lines like we talked about in class on Tuesday, if we have two lines and if there's a solution there, it's going to be where those two things cross. So our answer for this one should look like an ordered pair. So we have our x value. We need to find the y value of where these two intersect. And again, hopefully we remember that our ordered pairs are x comma y. So we've got our x, we need to find the y. So now let's take our x value, we can plug it into either one of our original equations. So let's maybe plug it into the red one right there. So what that looks like is y is equal to 1/2 times our x value of 6 minus 2. So when we evaluate this, we've got 6 times a half, or basically 6 divided by 2. So we have 3 minus 2, or our y value is equal to 1. But we're not done yet. We got to make our answer look like an ordered pair like this. So our final answer is 6, 1. So again, if we graph these two lines, y equals minus 1/2 x plus 4, y equals 1/2 x minus 2, they will intersect at this point 6, 1. That is the solution for the systems of equations. All right, folks, so the video is getting a little long. We're at 25 minutes here. What I'm going to do is I'm going to work through 23 and 24, put those in the filled in notes. What I would like you to do is to work those out on your own as well for a little extra practice. 23, you got to write your own equations to represent that farm for Farmer Cole. 24, they already give you the equations, but you just got to make sure that we are setting them equal to one variable in particular. I would recommend solving for x right away, so set them equal to x equals something because there's only one x in each. There's a little helpful hint for 24. But again, check those filled in notes for the solutions for 23 and 24. It's good practice. We're going to talk about this a ton again next week because this is going to be a big thing to take forward with Algebra 1. So last thing I'll leave you with for today is our homework for tonight is 4.1.2. 25 through 30. Please make sure that you take that Chapter 3 test if you haven't. Also, make sure that you get that homework collection in. And other than that, make sure you watch that video Monday as well. Again, super, super important one that you definitely do not want to miss. So otherwise, hope you all have a fantastic weekend. Enjoy the snow if you're an outdoorsy person. Otherwise, we'll see you all next week.